All right. Today we're diving into something we see every single day, but maybe don't think about enough. I'm talking about our sun. It's so much more than just a big light in the sky. So let's get right into it.
You know, we tend to think of the sun as this steady, gentle source of warmth, right? But check this out. It's also a place of just unbelievable power. What you're looking at here is a solar flare. Think of the most powerful volcanic eruption on Earth, and then multiply that by millions. Yeah, it's a pretty stark reminder that the very star that gives us life could also, throw a serious wrench into our modern world.
Okay, so let's back up a little and start with the fundamentals. I mean, what is this star at the center of everything for us? And why is it so incredibly important? So here's the thing. On a cosmic scale, our sun, it's pretty average. Kind of like a medium-sized star in a universe full of giants and dwarfs. But for us, it is everything. It's the engine that keeps our planet from being a frozen rock in space. It gives us just the right amount of light and heat to keep things at a cozy 15 degrees Celsius on average, instead of, a completely lifeless -18. Without it, none of us would be here. Simple as that.
And it's not just about heat and light. The sun's influence is, well, it's immense. Get this, it makes up more than 99.8% of all the stuff in our entire solar system. That massive weight, that gravity, is what keeps every single planet from little Mercury all the way out to giant Jupiter locked in its orbit. It is, quite literally, the anchor that holds our entire solar system together.
Okay, so how does it actually work? How can one star just keep burning and burning so brightly for billions of years? Well, to find that answer, we've got to go deep inside, right into its core.
So where does all that incredible energy come from? I mean, we see the light, we feel the heat every day, but what's fueling this thing? It's obviously not like a campfire burning wood or coal. Nope, it's something way, way more powerful.
The secret sauce here is something called nuclear fusion. Deep down in the sun's core, the pressure is just crushing, and it's insanely hot. We're talking over 15 million degrees Celsius. Under those conditions, hydrogen atoms literally get squeezed together so hard they fuse and become helium. And when that happens, a tiny bit of their mass gets converted into a huge amount of energy. To give you an idea of the scale, every single second, the sun is fusing about 600 million tons of hydrogen. It's just this perfectly balanced, non-stop nuclear reaction.
And this is where it all happens, right there in the center, that insanely dense hot core. See, gravity is always trying to crush the sun inwards, and that constant squeezing creates the exact pressure cooker conditions you need to get that nuclear furnace going and keep it running.
Okay, get ready for a truly mind-bending fact. That energy, the light that's created in the core, it doesn't just shoot straight out, not even close. The sun is so incredibly dense that a single particle of light, a photon, bounces around inside it like a pinball for a really, really long time. We're talking hundreds of thousands of years, maybe even up to 1,000,000 years, before it finally struggles its way to the surface and escapes. All right, so that's the engine room. But what about the effects? Because all that energy doesn't just gently float out into space. The sun is an active, dynamic, and sometimes violent star. And all that activity can have a huge impact right here on Earth.
Yeah, this really sums it up perfectly. You've got this constant stream of particles called the solar wind, and then these massive eruptions, solar flares. And these are not just some far-off fireworks show. They can have very real, very serious effects on our super tech-dependent lives.
And one of the clearest signs of all this magnetic chaos? Sunspots. They might look like little dark freckles on the sun's face, but they're actually enormous, often planet-sized regions. What's happening is the magnetic fields there are so tangled and intense that they're basically putting a lid on the hot gas bubbling up from below. So these spots are a bit cooler, which is why they look darker to us.
But they're not just cool patches. Think of those tangled magnetic fields like rubber bands being twisted tighter and tighter. Eventually, they snap. And when they do, bam, they release a colossal burst of energy. That's a solar flare. And what's interesting is the number of these sunspots we see isn't random. It actually goes up and down in a pretty regular 11-year cycle, from a quiet period to a really active one.
Now, it's not all doom and gloom and potential disruptions. Sometimes, the sun's power creates something just absolutely beautiful. I'm talking about the aurora, the northern and southern lights. This incredible light show is a direct result of the sun's energy hitting our planet's atmosphere. So here's how it works, cause and effect. On the sun's side, you get a solar flare or just the solar wind, shooting charged particles out into space. Then, on Earth's side,
Our magnetic field acts like a shield, catching those particles and funneling them down towards the poles. When they slam into our atmosphere, they make the air glow, and that's what you see as the aurora. But here's the flip side. A really powerful blast can mess with our satellites and even cause problems for power grids down on the ground.
Okay, now let's pull way back. Let's look at the biggest picture of all. Because our sun, just like every other star out there, it has a life story. A beginning, a middle, and, yeah, an end.
Just look at this timeline. It's the sun's entire life story, past, present, and future. It all started about 4.6 billion years ago, from a giant cloud of gas and dust. Right now, we're in the good times. It's a stable, middle-aged star. But this isn't the end of the story. Fast forward about 5 billion years, the sun will run out of its main fuel, and it's going to swell up into a massive red giant, probably swallowing Mercury and Venus. After that, it'll puff away its outer layers, leaving behind the tiny, super dense core called a white dwarf.
So I guess the big takeaway is that our sun won't be around forever. It's on its own epic, cosmic journey. And we just happen to be living in this perfect, long, stable chapter that makes our existence possible. Pretty lucky, huh?
And as mind-blowing as our sun's story is, this really puts it all in perspective. Our star, it's just one of billions. In our galaxy, the Milky Way, there are something like 200 billion other stars. Every single one of those little pinpricks of light you see in the night sky is another sun, with its own story, maybe its own planets. It's just staggering to think about.
It really is humbling, isn't it? And it kind of leaves you with this one big question. When we look up at all those other stars, what are their stories? What journeys are they on? And what amazing things are happening on the worlds they shine on?